I'm not too sure why 2.17 has a star next to it, considering that mathematically it's actually a pretty trivial exercise, especially if you're familiar with Euler's formula and complex analysis, but regardless, let's do it. We want to show that the exponential form ae to the ikx plus be to the negative ikx is effectively equivalent to the sinusoid form of c cosine kx plus d sine kx. The way that we convert between complex exponentials and trig functions is to use Euler's identity, so e to the ikx is equal to cosine of kx plus I sine kx, and respectively e to the negative ikx is going to equal cosine of kx minus I sine kx. If we do this and we plug these into this result, then what we get is a cosine kx plus I times a sine kx plus b cosine kx minus I times b sine kx is equal to c cosine kx plus d sine kx. And then we're asked to find the relation between CD and AB, and then reverse it to get the opposite version. So first off, immediately we can sort of combine coefficients. So we see there's cosine under C, and then we have A and B under cosine. So A plus B has to necessarily equal C, and we also have that IA minus IB has to equal D, because IA and minus IB are sharing the sine term with D on the right side. These are the relations in terms of C and D, so we can rewrite them as C equals A plus B, and D equals I times A minus B. Now, immediately, hopefully you realize that we can sort of reverse this. So if we want to express A and B in terms of C and D, well, we can recognize that, okay, ID is equal to negative A plus B. Is that correct? Yeah, negative A plus B. So what we can say is that, okay, well, C plus ID is going to equal A plus B minus A plus B. So therefore, B is equal to 1/2 of C plus ID, since the two A's cancel out, we're left with 2B. Similarly, C minus ID is going to give us, let's see, A plus B, and then plus A minus B. So that means A is going to equal 1/2 C minus ID. And that's our answer. We have our relation of getting C in terms of D, I mean C and D in terms of A and B, and then we also have A and B in terms of C and D, respectively.